Hari Om dear children, welcome you all to the chemistry class of standard 10 CBSE syllabus. Here we have started the first chapter of CBSE chemistry portion, and that is chemical equation and chemical reaction. Chemical reaction and chemical equation. In this chapter we are mainly discussing about what does a chemical equation represent and how can we balance a chemical equation, and what are the different types of chemical reactions. These are the main content in this chapter. And we have already, in the first video, we have already started the chapter, and there we have discussed what are reactants and products. In a chemical equation, what does a chemical equation represent? That also we have discussed. A chemical equation represents a chemical reaction. When a chemical reaction is conducted, it can be represented in the form of an equation. That is a chemical equation. A chemical equation actually represents a chemical reaction. When we burn coal in air, that is C react with O2, gives CO2. That is C plus O2 gives CO2. That is a chemical equation. So a chemical equation actually represents a chemical reaction. In the nature, nothing is created, nothing is destroyed. That is the law of conservation of mass. Every chemical reaction follows law of conservation of mass. That's why we have to balance a chemical equation. Why do we balance a chemical equation? That is a question always arises in the minds of us. Why do we balance a chemical equation? After writing a chemical equation, we are balancing the equation by putting some numbers in front of the formula or the number of atoms. We balance on both sides, that is on LHS and RHS. That we are doing. Why do we balance the both sides, LHS and RHS, left hand side and right hand side? Why do we balance? Because the answer is this, that is, every chemical reaction in nature obeys law of conservation of mass. What does the law of conservation of mass say? That is, in nature, nothing is created, nothing is destroyed. Matter can neither be created nor destroyed. Mass can neither be created nor destroyed. That is why according to that law, every chemical reaction obeys this law also. That's why we are balancing a chemical reaction. See here, this is a chemical reaction, that is Zn plus H2SO4 gives ZnSO4 plus H2. This is, how can we rate this? This is a chemical equation, you know. And this is a chemical equation, that is here, zinc react with sulfuric acid, gives zinc sulfate and hydrogen. Here, zinc is a metal that is in the solid state. Then sulfuric acid in the liquid state, and zinc sulfate also in the aqueous solution. That will be in the aqueous in the liquid form. That is here a liquid also, we can say this is in the liquid state. And here H2 is a gas, that is a lot of bubbles are arising out of the beaker in which the reaction has conducted. And also here we can see that the hydrogen gas is coming out. So in this reaction, let us check whether this is a balanced equation or not. For that, we can put 3 columns like this. This first column for element, we can write what are the elements present. Zinc and hydrogen and sulfur and then oxygen. Zinc, hydrogen, sulfur and oxygen. On LHS 1 zinc, RHS 1 zinc. Hydrogen, here 2 hydrogen, here also 2 hydrogen. Then here sulfur, 1 sulfur, here also 1 sulfur. Here oxygen 4 and here oxygen 4. So here both sides are equal. The number of atoms present on LHS, left hand side, LHS means left hand side of the equation, is also equal to the number of atoms present on right hand side of the equation. That means both sides are equal. Number of atoms on left hand side is equal to the number of atoms on right hand side. We say that this chemical equation is balanced. So we have to balance the chemical equation, because every chemical reaction follow the law of conservation of mass. What does that indicate? That is, the total mass of the reactants will be equal to the total mass of the product. The total mass of all the atoms present on left hand side will be equal to the total mass of all the atoms present on the right hand side. That is, the matter is neither created nor destroyed. That is, this is the law of conservation of mass. So every equation, every chemical reaction obey law of conservation of mass. That is the reason why we are balancing a chemical equation. Another example for balancing the chemical equation, that is here, Fe plus H2O gives Fe3O4 plus H2. That is, iron react with steam or water, we get iron oxide Fe3O4 plus hydrogen. So this is an equation. In this equation, first for balancing, first we have to draw a box around the symbol or formula like this. We have to draw a box around the symbols of reactants and products. What is the purpose of this? Because we should not change anything inside. We should not put any number inside. Only we have the freedom to put some numbers or change some numbers in front of the formula or symbols. In front of the formula or symbols, we can put some other numbers or we can change number like that. That is the method is called trial and error method. Trial and error method we can adopt for balancing this equation. Here we can change some number in front of the formula or symbols only, because we should not do anything inside. That is, we should not write anything in between here or here down, like that is as a subscript below. That is why we are drawing a box around these symbols and formula. So first you have to draw that, don't forget. And then after that you write what are the number of atoms of each elements present on left side and right side. Then by starting with the number of atoms, that is in large number, that is here oxygen is in the highest number on right hand side. From that atom we can start for balancing by putting a number, that is here on right side 4 oxygen present. So in order to balance that, we can put here only 1 oxygen. So here we can put 4. So when we put here 4, this become 4 now. Now this become 4. Now this has become 4. So now oxygen is 4. Here also 4. Then here one element now increased, that is hydrogen. Here 4 into 2, now it becomes 8. Now the element hydrogen is now 8 in number. So that also we have to increase on the right side. How can we increase that? By putting a number 4 here. We can put 4 here in front of H2. H2, in front of H2 you put 4, then we get 4 into 2, 8. So this also will become 8. Then next comes, so here now hydrogen is now balanced. Here 8 and also here 8. Oxygen is balanced, here 4 and here 4. Hydrogen balanced, oxygen also balanced. Then iron, here iron only 1. Here iron 3. So we have to increase the number of iron on the left hand side by putting 3 in front of the symbol iron, Fe. In front of Fe we can put 3, so that here the number of iron atoms now become 3. So now this is also balanced. So now iron is balanced, hydrogen is balanced, then oxygen also is balanced. In this way we can balance a chemical equation. This is called trial and error method, or hit and trial method, we can say. By putting some numbers in front, and we can change that number, and finally we come to a conclusion that the number of atoms on left hand side and right hand side are equal. Like when we buy some apple or oranges, we are doing the same thing by putting one by one. First we put a lot of apples, then we take one by one out, just in order to balance the two pan. Similarly, here also we are by putting some numbers, by trial method we are putting some numbers, and we are making the two sides, the number of atoms, equal. Such equation is called a balanced chemical equation. So what do you mean by a balanced chemical equation? A chemical equation in which the number of atoms of elements present on both sides of the equation are equal. Such an equation is called a balanced chemical equation. So why do we balance a chemical equation? Because every chemical equation obey law of conservation of mass. That is why we are balancing a chemical equation. So these two questions are here for your public exam. That is, why do we balance a chemical equation? Because every chemical reaction follow a law of conservation of mass. That is why we have to balance a chemical equation. Then what is meant by a balanced chemical equation? And that's also another question. That is, a balanced chemical equation means a chemical equation in which the number of atoms of different elements present on both sides of the chemical equation are equal. That is, the number of atoms on left hand side and number of atoms on right hand side of a chemical equation are equal. Such a chemical equation is called balanced chemical equation. These two questions are the expected question of this portion. And then from this portion you can also have another type of questions. Balance the given equation. Such questions also we can have. That question like this, they will give an equation and you have to balance that, and finally you can write this is the balanced equation. After balancing the chemical equation, we can also write the balanced chemical equation in the end like this by removing the boxes. And also here some letters are written as a subscript. That is, here solid. Iron is in the solid state. Water, that is in the gaseous state. That is, steam is used here. Water can be in the form of steam also. Here, gaseous state of water. Iron react with the steam. That is the meaning. Gas. Then Fe3O4. That is also in the solid state. That is solid. Here, hydrogen is in the gaseous state. So all the physical state of the reactants and products are written as a subscript below. Let us see another equation. Usually in an equation, there will be some pressure terms or temperature terms usually written above the arrow or below the arrow. That is, this carbon monoxide gaseous state gas react with hydrogen, that is also in the gaseous state. Then in the arrow, above the arrow, 340 atmosphere it is written. That is, the pressure is indicated here above the arrow. So in a chemical equation, for understanding the pressure condition and temperature condition, then what are the catalysts present, all these we can include in the equation by putting the pressure, temperature, catalyst, etc. above and below the arrow. We can put like that. Here pressure term is written above the arrow, 340 atmosphere. Then sometimes if there is some temperature condition, that also we can write below the arrow. Sometimes catalyst used in a chemical equation will be written above the arrow. So we can use all these things. All these things can be included in a chemical equation. And here the physical state of the reactants, gas, and also the CH3OH methanol formed is also in the liquid state. That also shown liquid. So for liquid, that is in the bracket, small l is used. For aqueous solution, within the bracket, AQ is written, AQ. AQ is written within the bracket, and for liquid L is written, for gas G is written, for solid S is written like this. That is, it is written as a subscript. So all these are the informations that we are getting from a chemical equation. That is, what are the reactants? This left hand side, that indicate reactants. Here carbon monoxide and hydrogen are the reactants. Reactants are substances that are taking part in a chemical reaction. Then right hand side gives the products. That is, here methanol, CH3OH is the product. That is, methanol is the product which is also in the liquid state. That is the information we are getting. And this above the arrow, it is written 340 atmosphere. That shows the pressure condition for this reaction to take place is 340 atmosphere. So we are getting a lot of information from a chemical equation. That is why it is said that a chemical equation always represents a chemical reaction. Questions can be asked for the public exam or in your term exams. That is, balance the given equation. Such type of questions can be asked, and they may be given the word equation only. That is, sodium react with water, gives sodium hydroxide and hydrogen. This is the word equation. Only words are written, but no formula, no symbol. So we have to change that into symbols and formula, and we have to write the equation first. That for that, sodium Na, then water H2O, then sodium hydroxide NaOH, then hydrogen H2. Then after that, first step is, I have already told you, first step is putting a box around the symbol and formula, so that we should not change anything inside the box. We should not write anything inside the box. So that is a precautionary measure, we can say that like that. Then this is also, we can put this also inside the box. And after that, the number of atoms of reactants and products on left side, LHS, that is reactant side, RHS, that is product side. So sodium here 1, here also sodium 1. Then hydrogen here 2, here hydrogen 1 plus 2, 3. Oh, see, here it is 3, here it is more, here it is less. Then oxygen here 1, here also 1. So here only the change is in the hydrogen number. So first we have to correct the number of hydrogen on both sides. So automatically the equation will become a balanced equation. So here which side is having a low number of hydrogen, that we have to first check. Here hydrogen on the LHS is left hand side or reactant side is less. So that we can change by putting 2 here. This is a trial and error method or hit and trial method. So we can change the number. Then 2 into 2. Now the hydrogen now becomes 4. Now the hydrogen becomes 4. Here the hydrogen is now 1 plus 2, 3. So that also we have to increase. Now here now hydrogen is changed. The number of hydrogen is now here on the LHS is 4. On the RHS it is 3. Now the RHS side is less, contain less number of hydrogen. That also we have to increase by putting 2 here. By putting 2 here we can increase the, so here now 2 hydrogen and plus 2 hydrogen. Now it is changed into 4. Now the RHS also contain now 4 hydrogen. Now the hydrogen is balanced on both sides. And sodium now, now here sodium is now 2 in number. It is increased. So we have to change the number of, we have to increase the number of sodium atom on LHS by putting 2 here. Here the sodium also will increase in number. That is 2 here. Here now 2 sodium. Right side also 2 sodium. Left side hydrogen 4. Right side also hydrogen 4. Here oxygen now left side 2 and right side also. So this is a balanced chemical equation. 2Na plus 2H2O gives 2NaOH plus H2. Then after that you remove the bracket and you put the solid sodium is in the solid state, and water is in the liquid state. Then sodium hydroxide is in the liquid state, hydrogen is in the gaseous state. We can put the physical state as a subscript within the bracket SL, like that. So this is a balanced equation. This balanced equation we can write again in the at the end. That is, after balancing, you can remove the boxes and you can write the finished product. That is the balanced chemical equation. And also you can put the physical state. You can write the physical state of the reactants and products also. This is the way in which we have to balance a chemical equation. I think you have got an idea about how to balance the chemical equations, and you practice more number of equations of this type, and so that you become very easy to handle such equations. So balance the equation is a very important part in this portion. They will give a chemical equation and you have to balance, and after that you have to write the physical state also, and that is the balanced chemical equation. So please share this video to all. Then please kindly subscribe the channel also. Thank you. Hari Om.